Hello everyone, welcome to Solve First Classes. This is Tushar Shaw, and in this video we will be continuing to solve the BHU PET 2020 questions that we were solving since the last quite a lot of videos. Okay, I remember the count. There are so many videos regarding that, and we have solved up till question number 24 in the last video. So we will be continuing from question number 25 basically. Okay, so before just digging into the paper and solving the questions, let us firstly give a brief introduction about what BHU PET examination is, like a small introduction, then we'll be moving on to the question so that you can follow up with the question paper pattern accordingly. Okay, so BHU PET is an exam conducted by the Banaras Hindu University. Okay, Banaras Hindu University, which conducts this PET examination for all kinds of subjects, basically physics, chemistry, math, zoology, botany, all kinds of subjects. But we are concerned about the chemistry paper, so we will be discussing about chemistry. So MSc chemistry is the discipline that we are considered of. Okay. Then according to them, they this paper, basically this PET paper is conducted every year. They conduct this examination mid June or July every year. But this year, because of lockdown, it was not able to being held on June. So it has kind of extended, like the date has kind of extended. Okay. Now the question paper pattern says that it has 120 questions basically. Okay, and the question distribution I have already explained you in the first or the second videos of this set, so you may go check those videos out first. Okay, so among these 120 questions, we have for solving these 120 questions, we will be provided 2 hours. Okay, and basically this is extremely low in case of BHU, and if you compare it from other standard examinations, but this is what it is. We can't change the fact. Okay. So what we have to do is to try to solve the questions, like they have a difficulty level of questions kind of less in compared to the other difficult examinations like TIFR and GATE and all those examinations. But as though the difficulty level is kind of less, it is still not manageable to solve 120 questions in 2 hours. Okay. So then, for each the correct answer that you will be attempting, you will be provided 2 marks. Okay, and for each negative marking, for each question that you did not attend, like for each of the question that you missed out, or maybe attended the wrong option, then you will be deducted half marks for that. Okay. So this was all about the question pattern. So let us now look at the exact paper. Let us look at the question from which we left in the last video, and then let us start solving. Okay. So question number 25, as I said already. Mm, yeah. So question number 25 says nicotine methiodide on oxidation gives. Okay. So let me just draw the structure for nicotine methiodide only, because many a time students don't know this structure only. Okay, they don't know basically, if you know the oxidation mechanism, you might know the how for any structure, if you provide certain amount of reagent, certain kinds of reagent, the many kinds of oxidation would take place. But the main problem, as I have already explained in my earlier videos, is that many a times the name of the compound which is given to you, that is already unknown to you. So how can you just proceed with the mechanism and give up the those kind of structures? Okay, so let me just draw the structure of nicotine methylate for you. um, so we have N, N, we have this one, then again we have this ring. Okay, here we have one H, here we have one methyl, and here we have one methyl, and obviously this N is plus charge, so we will be getting minus charge over here as a whole for this compound. Basically this is an ionic compound. Okay, so this is known as nicotine methiodide. Okay, Now, like as you all know, the what nicotine is, what are the like basic uses, and how nicotine is used harmfully in case of like many things. So let me just point out that it might be helping you a lot. So nicotine is basically a very poisonous alkaloid. Okay, the structure is an alkaloid. Now, what alkaloids are, I'll be explaining to you some other video. Okay, so this is a very poisonous alkaloid. Okay, poisonous alkaloid, and obviously in pure state it is colorless, pungent, have a pungent smell, oily, and acrid burning taste. Acrid burning taste. Okay. Now, as you all know that this nicotine is a constituent of tobacco. Okay, like tobacco produces nicotine as one of its chemicals which is there in the tobacco, and which is basically used in cigarettes and stuff. Okay, like and obviously like except for cigarettes, it can be used orally or for inhalation. Okay, so all this kind of stuffs yeah, so this is basically the like what nicotine is all about. So the structure of nicotine and the few introduction of nicotine is already done. Now let us look at the oxidation that this nicotine methavodide derivative would be going through. Okay, now oxidation is basically the kind of oxidation that we are talking about over here is from HNO3. Okay, oxidation may take place from alkaline KMnO4, or you may say H2O2 oxidation. All kinds of oxidizing reagents are already present. You already know these stuffs. But we are talking about acidic oxidation over here, because you can see that acids are formed at the end of the like in the option that are given. This from this you get the hint that you need to do the acidic oxidation, and that is why you will be taking nitric acid as your oxidizing agent. Okay. So yeah, so this was the like brief introduction. So now let us look at the mechanism about how this nicotine methylphenidate oxidation would be going through, and what will be the product that will be occurring. Okay, so mechanism. So let me just draw the structures for you. So we'll be starting directly from nicotine. Okay, um, and then we'll be moving on to like conversion to nicotine methylphenidate, and then uh, Me, and here we have H. Okay, so this is S nicotine. We give HI obviously. Okay, so like HI is given. So what would happen is this nitrogen would be taking up that H. H is over here, and yeah. So here the H will be remaining as it is. Why am why am I mentioning this H like so many times? Because it will be of future purposes. Okay. So here the N will be plus charge, and obviously you can see that this N is now sp3 hybridized. Okay, and sp3 hybridized nitrogen is more basic than the sp2 hybridized one. Okay, so like if after this you have to give MEI in this case. So what would happen is like here we will be having one Me also. Okay, and then again this structure we have H over here, Me over here, and we have all this here we have the plus charge. Okay, now here is obviously the H again present, and this one would be positive charge, and in the overall structure we have I minus already present. Okay, so in this case also I minus will be present in the system. So now what would happen is we will be providing OH minus into the system. Okay, OH minus. So what would happen is this OH minus would be like attacking into the this pyridine, this carbon on the pyridine ring, and this bond like I'm sorry. Um, okay, so this bond will be opening up. Then we'll be getting, and another OH minus would also be attacking. Okay, another OH minus will be attacking. So that what would that do? This would take up this H, and this bond will be going up. Okay, so we will be getting a product like N Me. Okay, here we will be having OH and H, and here we will be having Me and H. Okay, again, what we will be doing is we will be providing K4FeCN6. Okay, this is basically a reagent that we require. So K4FeCN6, I'm sorry, not K4, K3FeCN6. This is basically an oxidizing agent too. Okay, so what would this do? How K3FeCN6 is an oxidizing agent? K3FeCN6 has the let me just write it down over here. So K3FeCN6 has Fe under +3 state. Okay, so this would be taking up electron from one of the species, getting it reduced to Fe2 plus, and thus oxidizing the corresponding compound from which it has taken up the electron. Okay, so that is how the K3 FeCN6 reaction oxidation works. So like in organic chemistry, what would be the difference in the like how will the oxidation take place? So only this OH and H would be directly converted to double bond O. Okay, so we will be getting N. Okay, we have double bonds over here. Then directly we'll be providing the main oxidizing reagent that we have talked about in the earlier in this video, which is basically HNO3. Okay, so what would happen is if you provide HNO3, this bond will be breaking, and we'll be getting one COH group. Okay, so we'll be getting directly. I'm sorry, not S, N, Me. We have here we have COH, and here we have H basically. Okay, this carbon has a configuration S, so this name is S hygrenic acid. Hygrenic acid. Okay, or you may also write it as N-methyl proline. Okay, N-methyl proline. Basically, the structure of proline is this one, N H C O H. This is the structure of proline, as you all know. Okay, the proline is an amino acid. But those are not our concerns, obviously, because we require the mechanism and the exact product. Now, N-methylprotein is also known as hyaluronic acid. You must know and understand the fact, and after that only you will be like this is one of the difficult questions that was given in this question paper, because though you know the how if you know the how oxidation works, basically it's not a very extremely difficult mechanism. But even if you have known the mechanism, still it would have been like very difficult for you to understand the reagents that are given to you and to understand the products that are being asked. Okay, so from that, like I hope you have learned a lot about this nicotine methylate oxidation. I've explained all the structures, all these kind of stuff have all been done. So let us end this video here. Okay, I hope you have learned a lot. You have, here we have a mistake over here. So you have learned a lot about how oxidation works, what is nicotine, and what is this methyl iodide derivative, and what would be the exact like appropriate products that will be formed, and according to the mechanism that we have followed. Okay, so let us end the video here. So thank you guys for this video. I'll see you in the next one, and in the next video we'll be solving, obviously, as we solved question number 25 here. We'll be solve it from question number 26 in the next video. Okay, so thank you.